first. Okay, evolution of operating system. First one is no operating system. No operating system, that means late 1940 to mid 1950. That time, uh, process has done uh, with directly with the hardware devices. So no operating system execute there. Serial processing was there. That means process program one after the other. After completing one execution, then the second one executed. Single user system was there, that only one user could be able to access the machine, use the machine. The programmer user directly interact with the hardware. No operating system used, then program loaded directly to the computer. Machine runs from the console with the display lights. Toggles, switches, that means small switches have to move the likewise. Or the functionality is done with the machinery, that means with the small switches. Then features, manual program scheduling. So a user has to manually schedule the program one after the other. Then unit programming was there. Processor set idle. Idle means ready when the loading program and doing input output event. That means if one process is executing, the other program has to be idle until first one complete. Just even think about you are playing the cassette recorder, the old one. So other songs has to be idle and wait when the first one is complete. So at the moment you don't have the cassette piece also. So earlier we had the cassette tape. First song is singing, then after that other songs has to keep idle, then the other one, like one after the other. So here also, first complete the first program, then the other program processor has to idle until the other programs are loading. Then complete the first one, then start the next one. So next program has to wait till the first one complete. So processor set idle when loading a program and doing input output. Actually, this idle means ready and wait. I just want to show you by the time the process execution. Just look at this diagram. Okay, so now you can see seven states. When the process is executing, there are seven states in our machine. In our computer, the process is moving seven states. So execution is happening in the running state. The running mean execute. So it is happening in the random access memory. All the other things are, some are block state, some are ready state. Ready state means while waiting, that means before execute, it is just ready. Until it start, it is ready. So this state we call idle. Idle means before executing, thus just ready for the execution. Start වෙන්න පටන් ගන්න ඕන මෙන්න. හැබැයි start වෙලා නැහැ. Execute වෙලා නැහැ, idle. අර කාර්යයක් start කරපු ගමන්ම කියන්නේ execution එක යන්නේ පටන් ගන්න හදනකොටම වගේ. හැබැයි execute වෙලා නැහැ. idle කියන්නේ load වෙලා බලාගෙන ඉන්නවා run වෙනකම්. හැබැයි ඇතුළට ඇවිල්ලා load වෙලා තියෙන. But it is waiting until for the execution happens. Okay. So you will do this one later on. I think you didn't write this one. Manual procession after this one, features. Copy down this one. Next one is simple batch system. So after first generation of the operating system, the first one is no operating system. The machine works without any operating system. Then it actually don't tell it as a generation, just first machines without a operating system. Then second type simple batch system introduced to maximize the process utilization. Programs recorded in a magnetic tape with inexpensive mechanism. Earlier days, magnetic tape was used to store data. That means most of the bank sectors also use the magnetic tape. So operating system loaded and executed programs in a tape one at a time. So one program execute first time, then the next one. When the current program ended execution, its output was written to another tape and operating system loaded for the next program. So first complete first program, then load the second part. Just look at that point again. When the current program ended execution, its output was written to another tape and OS loaded for the next program. At the end of the entire batch of the programs, output tape was printed and inexpensive machine. Okay, so given the output as a printout. That means simple batch system also that first program execute, then it's saving another one. Then the second program is going to execute. That also like a sequential uniprogram. At a one time, only one program could be able to execute. So no direct access to the hardware. Therefore, that means since there is a simple batch system, user could not be able, no need to access the hardware devices directly. Okay, that means hardware devices are hidden from the user with the help of this software. Uniprogramming, that means one program executed at a time. High response time. It took some certain period of time to give the response because it's delaying compared to day one. So the processor set idle means ready, then loaded and ready for the execution, but it is not executed. Processor set idle during the input output. So while input output is going on, then processor has to be keep idle. Only one process is running at a time, so it is not going to share the processor or whatever. So it's just give a chance for the program to be executed, single program, and after that, until input output occurs, processor has to be idle and wait. Okay, shall we write these two slides? Third one is a multi-program batch system. So there are, as a result of this one, multi-program could be executed. Let's look at central theme of modern operating system. So this is the one which gave the central, the main theme, how the operating system is working in today's machines. That means modern OS, the basic idea of the modern OS given by this multi-program batch system. Introduce third generation to minimize the processor idle during the uh, processor idle time during input output. Okay, that means it is introduced the third generation to minimize the processor idle time during input output. That means processor loading and ready state, waiting some sort of time period until it execution. So likewise, so the idle, that means ready and waiting time during for the normal execution, not because of another program. Okay, so today in the diagram which I already shown you, that one is a today one. That is multiple processes are executing and simultaneously. So this means the waiting time until it start execution, that means idle time, then try to minimize. So introduce three generation to minimize the process idle time during input output. The process is partitioned to hold multiple programs. So that means processor partitions into several slots like cores. Today we are using core processors. That means IC, I3 to I5 like that. We have the four cores, single processor partition into four number of cores. So likewise, there are 4, 8, 16, like can be partition and keep. That it means it gives it present like 4 processes. Then it work like 8 processes like so that depend on the machine. So normally standard we have only four core processes. Or cores කියලා අපි count. If we divide into small slots, so that small slot we call core. So likewise, normally we have 4 cores. That means 4 processors. 4 small processors are inside the normal processor. Simultaneously, 4 process cycles can be executed. That 4 core processors. Just think there is a school, and school consists of 4 classes. Okay, so at one time, 4 classes can execute simultaneously. Okay, so likewise, 4 cores are in our computer standard one, but there are more than that 8 cores, 16 core can be there according to the generations. Normally, i7 up to i3, 5, normally 4 cores. Okay, so main memory is partitioned to hold multiple programs when current program waiting input-output operating system switches the processor to execute another program in memory. So that while one program is working, the other one is waiting for the input out. Then when it gets free, it will switches for the execution. So if memory is large enough to hold more program, processor could keep 100% busy. That means if the random access memory is the capacity of RAM is enough, then it will full busy. Why? Uh, the speed will reduce as a result of RAM. The RAM, according to the amount of capacity only we can execute, even though virtual memory is there this time. So entire process was depend on the memory capacity. So that means memory is large enough to hold more programs. Processor could keep 100% busy. Okay, so that means virtual memory concept don't take at this time. Now we have more functionalities with the help of virtual memory. Okay, write down this slide. Today we have time sharing. So time sharing means introduced to minimize the response time and maximize the user interaction during the program execution. Context switching concept is there. Context switching you will study, that means later. It enables share the processor time among the multiple programs. Multiple programs could be able to share the processor time. That means same time now, as I said, there are 4 cores and same time sharing the processor. As a result of now at the moment, just look at my machine of Zoom package also executing. That PowerPoint presentation is executing and the schedulers are working. So there are so many functionalities going on. So one is while one is executing, other apps are idle, ready and waiting for my uh, input event. Okay, so just think if I'm going to make it smaller presentation and then if I'm going to open another file, so these folders are waiting until I click it. That means it is waiting for another event to occur. Okay, so I just want to show you the context switching also. Look at this diagram. Context switching means when one program is executing, now then there are 2 programs are waiting. Process 1 and here process 2. 2 processes has to be executed. So here one process is running, then the other, and after it's stopping, then the things what has done it there, will save it. Then another process start executing. Okay. Then after it finishes, then the first one is start. For example, while writing, if you are sending messages, just imagine. Okay. Write the note, then start typing. Then again keep it, save the memory in the PCB we call process control block. So save it there, then start writing again. Then again typing. Likewise, if you are doing simultaneous work parallelly, then you have to keep in mind where you stop it and start the next work. Next. So likewise, parallel processes are happening today. So that time, one process has to be idle and wait. So while I'm explaining this part, what is happening for my previous slide is idle and wait for me. So then now I can start that one. Okay. So like we call it as a context switching. Multiple process programs simultaneously can execute with the result of the context switching. Can move from one file to another one and start execute it. Then the other one. Likewise, we can swap between uh, several process. Several program can be executed like that. So enable to share in the processor time among multiple programs. So as a result of time sharing, we could be able to share the processor time. So rapidly switching among processors. Then credits illusions of the concurrent executions of the multiple programs at the same time simultaneously there will be parallel processes happening parallel few executions are running on. Okay, so rapidly switching from one program to another one is switching between them. Okay, I'll copy this one of operating. Okay, what are the main important functions of the operating system? First one, process management, resource management, user interface, security protection. At the moment, we have the internet facilities as well. So it is not included there, just to know that. So resource management means memory management, input, output, device management, then provide the user-friendly user interactive interfaces for the user, and security protection. So security protection means it provides defender OS is the one which provides defend security protection. Okay, so those main four features are there, functions are there in the operating system. Right now.